Hi, I'm Christopher Eliot. I'm a professor in the Department of Philosophy at Hofstra, and as of this fall, I'll also be the advisor for a new program we're offering, which is a program in scientific reasoning and data analysis. We've put it together working with colleagues from philosophy and mathematics and computer science, and it'll be available to undergraduates in the fall. My area of expertise, which bridges philosophy and scientific reasoning, is philosophy of science, where we think about the justification of scientific knowledge and the relationship between scientific knowledge and our culture's broader projects and values. I'm looking forward to discussing Harry Collins' recent book, Are We All Scientific Experts Now?, which will be the summer reading for our incoming students. One thing that I found interesting and appealing about this book was that it developed a nuanced account of what scientific expertise is. A lot of people are skeptical of experts and authorities, and I think often they have a good reason to be, because experts and authorities don't always have our interests in mind when they tell us what we ought to believe. However, sometimes we need to trust experts, and Collins does a nice job of laying out what kinds of expertise make experts trustworthy, including scientific experts. Another thing I found appealing about this text is the advice that it gives to people in my field and the related fields of history and sociology of science, a set of areas that Collins calls science studies. And that is that when we think about how scientific knowledge works, when we think about how science produces knowledge, we ought to be careful about how we use examples and how we investigate science. So it's been too easy to focus on examples that are overly simplified. Toy examples like the experiments we read about just in the introduction to science books in our introductory classes, or to make a mistake by thinking that all scientific reasoning works like Isaac Newton's very successful reasoning. Those who have been critical of using those oversimplified examples, though, have historically emphasized the degree to which science is a messy human process done by complicated communities of human beings, with all the rivalries and competitions and human ambitions that are involved in all sorts of human communities, from local clubs to departments of professors. And those who've focused on science being a human, messy community that way have often made the opposite error in thinking that that's all science is. It's just a human process that produces results based on who speaks loudest and who has the most power in the scientific community. And I think that's a mistake too, and Collins does a nice job of advising us to try to find a middle way there. In understanding science as both messy and also successful for good reason. I'm a philosophy professor, so my job is to raise questions about arguments that people offer. And one of the arguments that I found really interesting that Collins offers is the argument that science succeeds because of the disinterestedness of scientists, that scientists are uniquely or especially personally virtuous, and it's those personal virtues that lead to the success of science. Well, I think that a lot of scientists are very good people, but I don't agree with Collins that it's the personal virtues of scientists that make science distinctly successful and trustworthy as a body of claims. And the reason for that is that I think science has often succeeded at producing good knowledge where the experts or scientists involved are not disinterested in the research they're doing. For example, all the time in medical research, researchers are trying to do something. They are interested, for instance, in producing a cure. And even in the case like Collins describes, where scientists are simply interested in their topic, that interest in wanting to learn more about the world is a kind of interest. Scientists have also tried to make money off of the research they've done, and I don't think any of those things have reliably gotten in the way of producing good knowledge. On the other hand, where scientists have produced good knowledge, it's often been due to something other than the objectivity of individual scientists. Rather, I think it's due generally to the scientific community functioning well, to it being well structured with things like appropriate criticism and in things like peer review, and also appropriately treating good work as good and not discriminating against it based on who wrote it, for instance. So I think it's that the scientific community and individual scientists do their jobs well and honestly, but in a way that reflects the general standards of their field, in the same way that carpenters and real estate assessors do their jobs well when they work according to the appropriate standards of their field. So I don't think it's that scientific success is mostly a matter of the objectivity of individual scientists, if that's even possible. So I really look forward to discussing this book over the summer and this fall with incoming students at Hofstra.